Okay, students, let us take up question number 28 of the paper. What it says is phosphorus pentachloride on. Okay, question is this much only. Phosphorus pentachloride. Choices are four. On hydrolysis gives an oxo acid of phosphorus, which is a good reducing agent. That means phosphorus pentachloride upon hydrolysis will give one oxo acid, which is a good reducing agent. Let us check. See, students. Phosphorus pentachloride undergoes hydrolysis in two ways. One with little water and another with excess of water. Little water means, say you take 1 mole of water and you can balance it. And if you say excess H2O, then you take 4 moles of H2O for 1 mole of PCl5. Well, with little water, PCl5 undergoes hydrolysis to give phosphorus oxychloride and to HCl. Phosphorus oxychloride is not an oxo acid. That means this should not be taken into consideration. What it says is oxo acid. Oxo acid stands for protic acid. That means we'll have to take this into consideration. That means when phosphorus pentachloride undergoes hydrolysis with excess of water, it gives H3PO4, orthophosphoric acid, along with 5 moles of HCl. Now look at this. Oxo acid of phosphorus is produced. Then let us check whether it is a good reducing agent. Good reducing agent. Look at this. We can guess whether it is oxidizing agent or reducing agent based on the oxidation state of the central element. Okay, central element is phosphorus and its oxidation state appears to be +5. Well, in the outermost shell of phosphorus, it has got 5 electrons. It has lost all the 5 electrons. That means it cannot give electrons. Therefore, it cannot act as a reducing agent. In fact, it acts as very good oxidizing agent. Therefore, this statement is partially correct and partially wrong, and hence this cannot be the choice. Is it clear, students? Now let us look at this. Phosphorus pentachloride has all 5 equivalent bonds. Well, phosphorus pentachloride means PCl5. It means that 5Cl has formed 5 bonds with phosphorus. That means we have 5 PCl bonds. Look at this. The structure is like this. It is in one plane we have 3 chlorine atoms, and one is above the plane and another one is below the plane. Well, this PCl bond is 240 picometer, and this in the plane PCl bond is 202 picometer. That means all the PCl bonds are not equivalent. That means even this is not correct. Okay, now look at this. Phosphorus pentachloride exists as an ionic solid in which cation stands for positive ion, has octahedral structure, and anion stands for negative ion. Anion has tetrahedral structure. Just look at this. PCl5 exists as dimer, dimer as P2Cl10. This can be written, this can be shown in this way. PCl4 plus, which is cation, which is tetrahedral. Cation, it says octahedral. But cation, 4 bonds, tetrahedral. Anion, 6 bonds, octahedral. See, students, here. Cation is octahedral and anion is tetrahedral. That means it is not correctly spelled. It is mismatched. Therefore, even this is wrong. See, students, here we have only 1 correct questions. Out of 4 choices, we have only 1 correct answer. 3 are wrong here. Perfectly 3 are wrong. That means the other one whose knowledge, even if you do not know, that can be the correct answer. Look at this. Let us check anyhow. On hydrolysis gives an oxo acid. Yes, once again we come here only. Oxo acid of phosphorus, which is tribasic. Tribasic stands for, here students, P OH double bond O, H3PO4. This is the structure of phosphoric acid. This OH bond is easily ionizable when it is added to water. That means 1 molecule of phosphoric acid produces 3 moles 1 mole of phosphoric acid produces 3 moles of H plus, or 1 molecule of phosphoric acid produces 3 H plus. That means its basicity is 3. That means on hydrolysis, phosphorus pentachloride gives oxo acid, which is tribasic. That means it is the correct answer. Clear, students? Now let's take another example, another question.